It's always a good idea to make sure an initial example makes sense before you move on to the next one. But in this case, I would strongly recommend that if match problem 1 didn't completely make sense, watch through that video again, work through that problem again. Match problem 2 now is going to get a little bit more complicated. We're going to have more work to do, more critical points to consider. So you're just going to want to ensure that this process makes sense before we start complicating things even a little bit more. But our process starts the same here. We'll first find the derivative of our given function with respect to x, which in this case will be 3x squared minus 6y equals 0. So we can't initially solve this because we still have two variables. So before we can solve this, we'll need another equation. We'll need to basically end up solving a system of equations. So we'll go ahead and find our first derivative with respect to y, which in this case is going to be 2y minus 6x, which is equal to 0. There are multiple different ways to go about solving this system. One method is to take this first equation and solve it for y, which in this case we would add 6x to both sides, then divide by 2, so that would give us y equals 3x. So we can come back to our original equation, 3x squared minus 6, and then in place of y we can substitute 3x equals 0. So we can factor out 3x since that's common here, which is going to leave us with x minus 6 is equal to 0, which means we have two possible values for x to consider, 0 and 6. So we have two different possible values for x. So we're going to take our derivative with respect to y and branch this off. One case is going to be our case where x equals 0, and the other our case where x equals 6. So we'll plug those in for x and find that corresponding y value. So y is going to be equal to 3 times 0, which means y equals 0. Y is going to be equal to 3 times 6, which means y is equal to 18. So in this case, our critical values, or our critical points to consider, are the point x equals 0, y equals 0, and x equals 6, y equals 18. So since we have 2 points to consider, we're going to have to calculate values for a, b, and c for this point and for this point separately, and complete that whole first derivative or second derivative test for both of these sets of points. So we're going to have to look at classifying both of these points individually. So before we do that, we can at least look at finding the second derivative with respect to x, the first derivative with respect to x, second derivative with respect to y, and find the first derivative with respect to y, second derivative with respect to y. So at least these three pieces of information, these second derivatives, we'll need for both of these points. So our second derivative with respect to x is going to be 6x. Our second derivative with respect to y is going to be negative 6. And our second derivative with respect to y is going to equal 2. So in this case, two of these results are just constants, but this first expression is dependent on whatever our value for x is. So this is why we're going to have to consider these individually. X has a different value in the first point than it does in the second point. So what we'll do is just split this up to consider these two cases separately. And we'll first look at the point 0, 0. So here, our value for capital A will be equal to the second derivative evaluated at x, evaluated at the point 0, 0. So we look at our second derivative with respect to x, evaluated at x equals 0. That's going to give us 6 times 0, or 6. For b, we're going to look at the first derivative with respect to x, second derivative with respect to y, evaluated at 0, 0. In this case, that's always just a constant, so that's negative 6. And our value for c is going to be both derivatives with respect to y, evaluated at 0, 0, which again in this case is just a constant, so that'll be 2. So we'll calculate AC minus B squared, which in this case A is, sorry, I made a mistake back here. 6 times 0 should be 0, not 6. So A times C is going to be 0 times negative 6, so that's going to be 0, minus B squared is going to be negative 6 squared, so 0 minus 36 is going to be negative 36, which is less than 0. So since AC minus B squared is less than 0, f of 0, 0 is a saddle point, which again means the same thing as saying that our function does not have an extremum at this point 0, 0. So we can either kind of shortly say that's a saddle point or say that no extremum exists. So now we need to go through the exact same process for 6, 18. So our value for A is going to be both derivatives evaluated at x, and then that expression evaluated at 6, 18. So that will be 6 times 6, because we're evaluating this expression here. So that'll be 36. And then since our values for the second derivatives with respect to y are both just constants, b is still negative 6, and c is still 2. So we'll look at AC minus B squared, which in this case will be 36 times 2 minus negative 6 squared. So that result is going to be something greater than 0. So then we need to consider our value A. So AC minus B squared is something greater than 0. In this case, A is equal to 36, which is greater than 0, which means we have a local minimum. At f of 6, 18. So 0, 0 is nothing of interest. It's not a local extremum. 6, 18 is a local minimum in this case.